good afternoon, and good morning to all the participants joining us from all over the world. Thank you very much for joining in this important webinar by ISGF. And I would like to welcome you all on behalf of India Smart Grid Forum to the webinar on enabling vehicle to grid in India, unlocking the potential of EVs in grid resilience. So here's a quick introduction of the webinar. As India is rapidly transitioning towards clean mobility, with the government of India targeting over 30% of EVs on roads by 2030, proper planning is essential to build a robust grid that can efficiently support public, private, and captive EV charging stations across the cities and highways. To explore this important emerging opportunity, ISGF has led a pioneering V2G pilot project, the first of its kind in South Asia. This initiative demonstrates the technical and economic feasibility of green electricity-based EV charging and V2G integration in India. ISGF, with technical support from University of Delaware, USA, successfully executed the first of its kind pilot project, demonstration project of V2G technology in South Asia. In this webinar, we will explore the technical, commercial, and regulatory aspect of V2G. We will discuss the role of EVs in enhancing grid flexibility and resilience. We will identify actionable policy recommendations for national scale-up and highlight ecosystem readiness from technology and utility preparedness to enabling policies and market mechanism. Before we proceed, we request all the participants to please be on mute, keep your cameras off so that speakers can deliver their presentation and the keynotes smoothly. And if you have any queries or questions regarding the pilot project or the speakers panel discussion, please put that in the chat box and we will be taking all your questions after the panel discussion. Here's a quick glimpse at today's agenda. We will start with a welcome address, followed by special address by CEA, and then there will be a presentation by ISGF, followed by a panel discussion moderated by Ms. Reena Suri from ISGF, and it will be followed by question and answer round. Our welcome address will be given by Mr. Rejikumar Pillai, President, India Smart Grid Forum. For the special address, Mr. Ghanshyam Prasadji from CEA will join us. Mr. Ghanshyam Prasadji has been called for an important meeting, so he will try to join as and when possible for him. Moving ahead, there will be a presentation by Mr. Anand Singh from ISGF, and the panel discussion will be moderated by Ms. Reena Suri, Executive Director, India Smart Grid Forum. Our esteemed panelists include Mr. Ravindra Kadam from CERC, Ms. Rodney McGee from University of Delaware, Mr. Abhishek Ranjan from BSES Rajdhani Power Limited, Mr. Narendra Nath Veluri, CEO Anerd, Mr. H.C. Sharma from Tata Power Delhi Distribution Limited, Mr. Rajesh Kumar from BSES Rajdhani Yamuna Power Limited, Mr. Omkar Shaligram from Tata Motors Limited, and Mr. Balaji from Shakti Foundation. Now, to move ahead, we would like to welcome Mr. Rejikumar Pillai. He is the President of India Smart Grid Forum and Chairman of Global Smart Energy Federation. He is an internationally renowned expert with nearly 4 decades of experience in the electricity sector in diverse functions covering the entire value chain and across continents. Welcome, sir.
Thank you. Good morning, good afternoon, good evening to all the participants from around the globe. It's my great honor and pleasure to welcome you all for this webinar on the pilot demonstration project we have undertaken in India on AC V2G. As many of you know, V2G demonstration projects and small scale rollout has happened across the globe in different countries in different points in time, but no places it has been rolled out massively. And the only program which is progressing currently is the school bus electrification program funded by US Department of Energy in USA. In some states it's going fast. Otherwise, we are honored to have University of Delaware, USA as our technology partner for this pilot demonstration project. In fact, AC V2G was first time demonstrated in the world by University of Delaware way back in 2008, 2009. Rodney is here from UDEL. He will be talking about that as well. A fleet of 30 to 40 vehicles were uh, retrofitted with AC V2G functionality and demonstrated it. Voltage and frequency regulation was provided to PJM grid long back. But is there any regulation in USA? No. Is there any regulation in Europe? No. None of the places the regulations are there, are not there. And as a result, V2G has not taken off. Although in the initial years, when the V2G was demonstrated successfully in labs and in small pilots, the EV owners were apprehensive of the effect of V2G on the battery. And 10 years ago, battery in a car was much more expensive than what it is today. And they were afraid. Battery manufacturers, OEMs, they have given 1,000 cycle, 2,000 cycle, 3,000 cycle, and in a day 4 times charging and discharging is done. Will it be counted as a cycle, and will they lose that warranty? Is the main worry which people had. But the pilot projects conducted in several universities and research labs have clearly shown that shallow charging and discharging it has no adverse impact on the batteries of EVs which are participating in V2G. So this has given confidence over the years. Today, in many places, V2G, wherever it is offered with some incentive for the vehicle owners to participate, they have no worry about it. Typically, in a V2G program, it's a shallow discharging. Never the SOC, state of charge, never goes below 40%. Worst cases are 30%. And when you charge also, it comes to about 80-85%. So vehicle battery state of charge maintaining at 80, discharging up to 40, again going up to 80, it has minimum impact on the health of the battery. In fact, some of the white papers in the recent past have said that it has a massaging effect on the battery. It will extend the life of the battery. So now people have one, cost of the battery has come down drastically, and there is people are convinced that there is no adverse impact on the life of the battery. So it's the time for large scale V2G rollout, which is being limited only by regulations. So whenever ISGF has done demonstration project, we have done always with the support of the regulatory commissions, electricity regulators. They've been part of us. 5 years ago, we introduced blockchain technology for peer-to-peer trading of rooftop solar energy, and we have undertaken pilot project in Lucknow, Uttar Pradesh. So we have done it with the approval of the regulatory commission, and with the success of the project, a year later, UP regulatory commission issued the world's first guidelines or regulations for P2P trading of rooftop solar on blockchain. And now in India, there are 4 states where there are regulations: UP, Delhi, Karnataka, Kerala. 4 states have today conducive regulations for peer-to-peer trading of rooftop solar energy on blockchain platforms. Next is V2G. This project also we have done with the help of and close coordination with the regulatory commissions and government agencies. So we hope that there will be regulations soon. In fact, Kerala Regulatory Commission has already issued draft regulations for V2G. And as part of the project, we have prepared a model V2G regulations, which covers all aspects of V2G, from technology to standard to incentives. So which will be briefly presented by Anand after this. So we hope that there will be regulations, there will be incentive, and there will also be, we are also working with a host of OEMs, including Tata Motors, who have helped us in the retrofitting part, and now they are also interested in having a V2G variant of Tata Nexon soon. And we are also working with the charger developers locally for developing bidirectional AC chargers. So millions of homes have rooftop solar already, and another 10 million homes will have rooftop solar under the PM Suryaghar Yojana. And the picture of the grid is going to be entirely different. Tens of millions of points from there, power will be injected into the grid, which was inconceivable few years ago. And if there are electric vehicles with V2G functionalities connected to the same low tension or LT grid, distribution grid, with the cloud passing, there will be variation in the generation of or solar output of rooftop solar that can be immediately mitigated. Immediately the EV batteries can for a few minutes also pump electricity back to the grid for voltage and frequency stability. So this is going to be a great support for the grid operators, and we hope very soon, again, India will be the first country which will have V2G variant EVs on sale, and also have regulations across the country for V2G rollout. So thank you very much for everybody, and over to back to Sneha.
For the very interesting welcome address. Now we will invite Mr. Anand Singh from ISGF. He is currently working as General Manager, and he carries over 19 years of experience in smart grid and electric mobility space. Over to you, Anand.
Thank you, Sneh. May I request Bala to share the presentation? Welcome everyone, all the panelists and participants across the globe. So I have the privilege to share this story again, the V2G story, what we started 15 months back. And am I audible? Yes. So we started this 15 months back, and then I am allowed only 15 minutes to narrate the entire story. I'll try my best. Bala, if you can go to the next. Next. Yeah. So it's related to ISGF. I think most of you would be knowing what ISGF is. It's a public partnership initiative of our government of India. We are responsible for accelerated development of the smart grid technology in India. This effort is also one among them. We are more than 200 members, comprising ministries, utilities, technology providers, and academia. We are 9 working groups, and we are participating actively for the digitalization of utilities across India. Next slide, please. Next slide. Yeah, thank you. So it's the same old story. When we started this V2G, we didn't have anything. Neither we had a vehicle, nor we had a bi-directional charger, nor
Anand, can you be a little louder? It's not very clear.
Am I fine now? Can you hear me now?
A little better,
okay.
Yes.
Yeah, thank you. So when we started this, we didn't have anything, nor vehicle, nor neither vehicle, nor charger, not BMPU. But we had Reggie Pillai, and with his support and all his efforts, we have been able to do it once again. V2G is now technologically demonstrated in India. A little about what is V2G in a layman's language is just you can store electricity in your vehicle, and at the time of peak hours, you can send back your electricity to the grid so that it can help in grid flexibility. The key benefits from both the sides is it is going to serve the purpose in terms of making grid more flexible, and we'll talk more about this in coming slides. And then from consumer side, it allows you to a flow of electricity, and then you can optimize your total cost of your vehicle if you, as a consumer, you are participating in this journey. Next slide, please. We started this pilot more than a year ago, and the key objective of the V2G technology demonstration was promotion of renewable energy. We just discussed, and we just learned that there is full of renewable energy coming to the grid. So all the intermittency problem, and then variance in generation is going to be a big problem in times to come. So we found V2G as something that can actually create a cushion between the demand and supply gap. Grid balancing is one thing where it can help more, reducing peak power purchase cost, additional income for EV owners, and then RE integration and virtual power plant where it can actually help to stabilize the system. So the scope of project was we did it in two components. One was to demonstrate EV vehicle to grid technology, at least establish it that this is happening in India. Earlier it was available in US and several, I think in Europe also, but in India it was not existing. Another component was to ensure that your EV is being charged with green energy. So these are the two components. Next slide, please. Bala, can you hear me?
Yes, sir. I have displayed next slide.
Yes. So we as a technology partner, we have University of Delaware. Dr. Rodney will be talking more about this. Nuvve, we got bi-directional charger. Watt&Well, we imported BMPU to retrofit the Nexon vehicle. And as a project partner, we had BSES Rajdhani, BSES Yamuna, Tata Power Delhi Distribution Limited, and Inert, Government of Kerala. Project of Electricity Authority, Tata Motors was also there. And project, so it was. Can you hear me?
Yes, sir, we can hear you.
Right. So we had 4 vehicles, Tata Nexon vehicles, where we retrofitted all this. I'll explain and we'll show that how it was retrofitted. And we imported bi-directional charger from US, and then BMPU was also imported from US, and then all was done with help of University of Delaware. Dr. Rodney was here for more than a week, and then we spent more than a month in a Tata service center to make sure that we retrofit the rest of the 3 vehicles what Dr. Rodney has left in India. Please go ahead. Next slide. Yes. In a layman language term, if what we did is we used BMPU, bi-directional power unit, and then conventionally we have single phase AC charging 3.3 kilowatt. So with the help of BMPU, we give 3-phase AC connection. That was the capacity was 11 kilowatt. So with the help of BMPU, we converted that 11 kilowatt of AC to DC in the range of 300 to 350 volt, and then that energy was given to the battery that was inside the vehicle, and then reverse flow when that stored energy was converted to AC, and then it was given back to the grid. The capacity was 11 kilowatt, though we can raise up to 52 kilowatt with the same bi-directional charger. Next slide, please. Yes, so this was the charger left. If you see at the left side, this was the BMPU what we had imported. Then middle you can see the bi-directional charger what we used, and this we had with the help of Dr. Rodney UDEL. This EVCC was developed. So it is a parallel electric vehicle communication control. This was created in parallel ECU that on the Tata Nexon vehicle, and then we had this charging inlets and BSL through which we could demonstrate this. Next slide, please. Right. So these are the pilot sites. One was first is BRPL, and second is TPDDL, BYPL, and Inert. So these were 4 locations where we demonstrated this. Next slide, please. So this is typical application through which you can actually
track your charging discharging capabilities. So it is a web-based application given by Fleetbox application provided by Nuvve, so that you can track your charging and discharging of your vehicle. Next slide. This is 1 month charging discharging that is shown on the screen, where the upper green bar would it's showing that this is in charge, and then the blue bar is showing that the vehicle is being discharged. So in a month, the net charging was 254 kWh was used for charging, and then 152.3 kWh was fed to the grid. So net 101.9 kWh was used. So it's a very simple demonstration of how you're charging on a daily basis, how much your vehicle charged, and then how much was discharged during peak hours. When utility is hitting peak hour, then it makes more sense to discharge the vehicle and create a cushion for the grid. Yes. So the another component was showcasing that your vehicle or any EV can be charged with a green energy. So for purpose, we, with the help of a blockchain technology service provider, one charge point operator, and one AMI service provider, and then one app service provider, we tied up with everyone, and then this was made possible. So a solar generation power plant based on West Delhi, smart meter was put there to understand that in every 15-minute slot, how much solar energy is being generated. And then one app was already available, but we actually modified the app, and then now the app is able to give you another option, what will let you charge your vehicle by green energy with some premium. The app was modified, and with help of blockchain technology, we ensured that the same energy or more energy was fed into the grid in that very 15-minute slot when you are charging this vehicle at a charging station with the help of that modified app that was created by Electrify. So next slide, please. So once you charge your vehicle with help of blockchain technology, are generated, and then a certificate is generated. And this is the basic architecture of how this entire thing is happening. So at the left side, you can see that you have a EV SE or charging point there where your EV is connected. On the right side, there is a solar power plant, and we have smart metering arrangement as both the ends. And then with the help of blockchain technology, you are able to fetch data in every 15 minutes of interval, and then verify it with the help of blockchain technology. And then you generate tokens, then you generate the certificate. Can you go to the next slide? Please, Bala. Yes. So this is the typical application what we had, and then with the help of application, you give another option to charge your vehicle with green energy, and then a certificate is created at the end of the charging. When the charging is done, with help of 10 kWh, you generate one certificate. Next slide, please. Yes. So this is the certificate that was generated, one certificate for the charging. Next slide, please. Bala, if you can go to the next slide. Yes.
Yeah, I mean economic benefits.
Yeah. So these are the economic benefits of V2G for grid side as well as consumer side. So from grid side, if we look at it, that how it is helping grid is flexibility in power system operation, peak shaving, or maybe demand response in peak hours that can be done. Frequency control, That is also possible. Support of RE integration, particularly the rooftop solar variation in RTS generation, that can be smoothened. During peak solar hour, we can use those energy when the energy is cheaper in the grid, that can be stored in vehicle. Those hours can be utilized when you have ample solar energy, and that can be used to store in your cars, and then during peak load hours you can just feed it back to the grid when grid is needing more. Other ancillary services, voltage management and local condition of capacity management, that can be done. Increasing rate of renewable energy self-consumption, that is also possible. Optimization of back-end power, reducing grid infrastructure investment. So this is one of very important help what V2G can create. If you talk about this, we have more than 8,400 megawatt of or megawatt hour of peak load, and very soon this is going to touch 9,000, and the transmission capacity is way less than this. So now we are left with local storage through which we can actually defer that infrastructure augmentation cost. This can also provide at the time of disaster the great help when your vehicle can feed to a local grid. So this can be utilized then also. From consumer side, this is potential revenue generation, and then the frequency regulation, that benefit also can be reaped. Energy security is one thing, and then bringing down the total operational cost of the vehicle. So once you have V2G facility, you can buy at cheaper price, what we have actually suggested in our model regulation, and then you can feed it back to the grid at a higher price, what DISCOM and then several other stakeholders are going to decide. But definitely it should be more than the grid price you are buying. So that will create an arbitrage for consumer, and then this will help to reduce the total operational cost of the vehicle. Next slide. Can you go to the next slide, Bala?
Yes, sir. I mean, regulation is complete.
Yes. So we came up with model V2G regulation, and then we presented this also to forum of regulators. We have covered guidelines for V2G implementation, eligibility for participation, rules and responsibilities of different stakeholders, technical standards for V2G integration, metering requirement, communication interoperability, testing and certifications requirement, forecasting V2G availability, skill real-time operation, curtailment of emergency control, system monitoring and reporting, tariff framework, settlement principles, billing and payment mechanisms, financial incentives and subsidies. So all this we have discussed in detail that in the model regulation that is available at the web, and that is given there at the bottom. So this can be this is readily available over the net. This can be downloaded from there. Next slide, please. So during our research in how our model regulation should look like, or how our model regulation should be, this tariff is one thing that is going to decide that how we are going to technology for the masses. So energy injection tariff and ancillary services compensation, that is going to decide that how best we can push it. Time of uses tariff is also one thing what we have suggested in the regulation, though that is not in practice in India, but maybe we can go for smaller pilots to understand that how it is going to help the V2G implementation. Next slide, please. Bala, can you go to the next slide?
Yes, I'm in tariff design.
Yes. So before using how our tariff should look like. We studied a couple of models that is existing in terms of V2G. We studied Japan's model, UK model, Denmark model, California model, US model, then Australian model also, and then Netherlands also. So everywhere there is incentive, and that is very locally crafted so that it can help the utility. So we have proposed that during high solar generation hour, the cheaper electricity can be made available to the consumer at a lower price, and in peak hours when utility is going and buying the energy from the maybe less than that amount or can be given to the consumer so that it can discharge to the grid. So that arbitrage can be created to encourage V2G participants to join this exercise. Next. Next slide, please, Pala.
Sir, I mean way forward.
Yeah. So, I mean, the technology is demonstrated, that is reality. Then we have come up with a model regulation also. So it's like how we are going to push it to the reality when V2G becomes, I mean, it should scale up like the way we are seeing solar is being scaled up, residential solar, rooftop solar that is being scaled up in India. So coordinated effort of policymakers, utility, EV manufacturers, and then technology providers. So all stakeholders are equally important to push it to the reality. Adoption of standards, V2G, Bureau of Indian Standard is also there. And then charging and discharging operation. So we in India, we do not have the concept of aggregator so far, but I think this is the responsibility of DISCOM to understand the nitty-gritties of how they are going to, in the beginning, how they are going to play the role of aggregator, and then leave it to the market, open it to the market so that people can join and then take it forward. So primarily, I foresee that DISCOMs have more responsibility in this direction. And then EV OEMs to explore capabilities of V2G, enable EV manufacturing inside India. We can do this policies and regulation for incentivizing EV owners to participate in V2G program, and then distribution utilities to build DUMS platform. So this is coming up. We do not have DUMS available here, but obviously we can think of doing a pilot. V2G is now a reality. BRPL is aggressively working on it. I must appreciate that their EV team is almost sitting on my neck every day and making sure that it works every day. So here I'm ending my presentations. A question and answer can be taken up in open house when we open up. So thank you very much. Over to you, Sneha.
Thank you, Anand, for the very insightful presentation. Now we will move ahead with the panel discussion, and we will welcome all our esteemed panelists and our moderator. So starting with a short introduction, the panel will be moderated by Ms. Reena Suri. She is Executive Director at India Smart Grid Forum, and she brings over 20 years of rich experience in the energy sector. She has played a key role in various ISGF projects, including electrification plan for public transportation, blockchain for electric utilities, energy storage roadmap for India, and many more. Now we will invite our panelist. Our panelist, Mr. Ravindra Kadam, is a senior advisor, renewable energy at CERC, and he brings over 15 years of experience in the energy sector, covering a range of key issues such as renewable energy, power sector reforms, regulatory development, and many more. Welcome, Mr. Kadam. Our next esteemed panelist, Dr. Rodney McGee, is a faculty member of University of Delaware Department of Electrical and Computer Engineering, and he leads the Transport Electrification Center. Welcome, Mr. Rodney. Our esteemed panelist, Mr. Abhishek Ranjan, is a CEO and SVP at BSES Rajdhani Limited. With a track record of exemplary leadership, he brings over 2 decades of diverse experience in the industry, and under his leadership, BRPL is moving for a journey towards innovation and sustainable growth. Welcome, sir. Our esteemed panelist, Mr. Narendranath Velluri, is the CEO of Anert Kerala, and he has a strong support and interest in clean energy and plays a pivotal role in promoting decentralized solar energy in Kerala. Welcome, sir. Our esteemed panelist, Mr. H.C. Sharma, is heading the function that includes Chief Technical Services, Power Management, Power System Control, Quality and Sustainability, Business Development and Collaboration at Tata Power Delhi Distribution Limited. Mr. Sharma brings over 32 years of experience. Welcome, sir. Our next panelist, Mr. Brijesh Kumar, is Chief Operating Officer at BSES Yamuna Power Limited, and he has worked at various levels in different departments prior to becoming CEO at BYPL, and he brings a vast experience of working with the utility. Welcome, sir. Our next panelist, Mr. Omkar, is currently working as General Manager at Tata EV, the electric vehicle arm of Tata Motors, and he brings over 13 years of a rich experience in the automotive industry. Welcome, Mr. Omkar. Our next panelist, Mr. Balaji, is from Shakti Foundation, and he has contributed in substantial wealth of knowledge honed over more than a decade of professional experience in e-mobility, renewable energy and power sector. Welcome, Mr. Balaji. Now, I will hand over the stage to Ms. Reena Suri to take the panel discussion ahead. And before we proceed for the panel discussion, I'll request all our panelists, our moderator, Mr. Reggie Pillai and Mr. Anand Singh, to please join us for a group photo, and then we can proceed for a panel discussion. Our team will quickly take a screenshot of all the panelists.
I think some of them are missing. Narendraji, if you can switch on your camera, please.
It is switched on. I am able to see.
Yeah, he is very much there.
Oh, okay, sorry, I'm not able to see him for some reason. Welcome, Abhishek ji.
Hello, thank you.
Reena, when Mr. Ghanshyam Prasad joins, stop and give him 5 minutes. He's in the ministry, meeting with the minister. Whenever he is free, he said he will try to join for 5 minutes.
I'll surely. Please, Sneha, please inform me. Yeah?
Sure, I will. And thank you, everyone. We have captured a very good photo. Thank you so much. And we can proceed ahead with the panel discussion.
Thank you, Sneha. And I request the panelists to keep their cameras on if possible, and for all the participants to keep their microphones and cameras off for a fruitful discussion. So thank you, and a very good evening and a very warm welcome to everyone. It's a pleasure to welcome you all to this very important panel discussion, enabling vehicle to grid in India. And we have heard from Mr. Pillai and Anand about the importance and the work we have done. And as we stand at the cusp of the mobility revolution that we see in India and globally, the transition towards electric vehicle, is no longer a question of if, but it's a question of how fast and how smartly we can move towards that. And India has already committed to 30% of electric vehicles on road by 2030, and with the kind of trajectory India has, we are hoping to have even higher numbers. We plan to exceed over 80 million EVs by the end of this decade. And while this presents exciting opportunities for sustainable transport, it is also, it also raises important questions for our power sector. How will we manage the enormous energy demand for EV charging, and how, more importantly, how do we unlock the full potential of EVs as distributed energy assets? And that asset that can support not only draw power, but also support the grid at the time of peak power demand and bring flexibility. So with the vehicle to grid, as a concept, transformative concept that allows electric vehicles to give back to the grid during peak demand using bidirectional charging technology. In doing so, the electric vehicles then not just become the clean transport options, but also flexible and distributed energy assets. And I'm very happy that we at ISGF, along with our key partners, Central Electricity Authority, University of Delaware, BSES Rajdhani Power, BSES Yamuna Power Limited, and Tata Power Delhi Distribution Limited, and Enert from Kerala, and Tata Motors. All together, we have had the privilege of leading India's first vehicle to grid demonstration project. So thank you so much for your partnership and the support. I'm very happy to share that senior leaders from all partner organizations have taken time out and joined us to share their journey and their perspective around vehicle to grid, and we are very grateful for your commitment and support, which has been instrumental in bringing this innovative initiative to life. And lastly, not to miss Shakti Sustainable Foundation, who has been a key driver to and a knowledge partner for this project. So, with this diverse panel representing policy, regulation, utilities, technology, research, and manufacturing side, all a great mix of 360-degree perspective on how vehicle to grid can become a reality. So I once again welcome all the panelists, and would like to start with our first panelist, who's Mr. Ravindra Kadam from CRC. Just before we start with our experiences from the utility and our partners, would like to get some background on the regulatory perspective, which forms the foundation of any emerging energy solution like vehicle to grid to become a reality. Because without the right policies and pricing mechanisms, the V2G ecosystem cannot scale. So, Mr. Kadam, would like to hear from you a regulatory perspective, what fundamental changes are needed to support bidirectional charging and ensure appropriate pricing structures for V2G services, and what are the plans from CRC to help scale up the new innovative technology that we are looking forward to. So over to you.
Am I audible, first of all?
Yes, you're audible.
Yeah. Okay. First of all, thank you very much for inviting me. And before I start anything, let me also give one disclaimer, which I generally give, that my views should not be considered the views of the commission. Certainly, me being in the commissions, we do have certain discussions and the point of view, but still, the views would be completely my own and personal views. Then over to your question, Ms. Rina, absolutely, you are absolutely right. The regulatory framework is key in all these innovative technologies, and being a part, even though as a Central Electricity Regulatory Commission, we don't have a direct consumer as such to regulate directly. It is our counterpart, the state electricity regulatory commissions, who have direct, in that sense, as a role to play in order to define a regulatory framework for such innovative technology. But at the same time, CRC do have also another hat, where we actually try to harmonize and bring out certain regulatory sandbox or model regulations for all the state regulatory commissions in such kind of a new and innovative environment like V2G. So as part of that, we do certainly have a very critical role to sensitize the state regulators and make sure that the regulatory framework is in place, at least as and when the state regulators wants to adopt it, in considering the situation and considering the demand in their state. So as a part of that, I think certainly the forum of regulators who also have constituted a very active and proactive regulators group called RE working group, where all the RE states regulators are part of this working group and actively pursuing the development happening in the sector. As a part of that group, if you remember, and as you have rightly mentioned, that by the previous speakers that you people have been invited, and we had a long detailed discussions about the pilot, which you have executed, you have implemented, and the forum of regulator officially also noted that you are pilot, and I was quite appreciative of your effort to create to bring new technology and a new technology, implementing such kind of pilots. And ISGF, I think, is pioneering in all this. I think there are so many pilot projects you do keep implementing under the pilot, which actually, of course, push the regulators also to sensitize regulators to create a complementary regulatory framework. So I think I must congratulate you once again for this new this pilot. And so to say, if you ask me from a regulator perspective, I think the major two key issues I think was going to be like how this tariff structure, the dynamic tariff structures, is going to be a reality in the regulatory sector, so that this particular technology, new innovative technology, can really respond immediately to that kind of a dynamic pricing in the electricity. And I think that is the key and very preliminary, I would say, the requirement in the regulatory this thing. And for that, certainly, I think the forum of regulator is creating certain kind of a framework to allow such kind of a dynamic pricing. We also, as I was mentioning, the forum of regulator has a role of bringing out that homogeneous regulatory model regulations, which becomes easily adoptable by the states depending upon their state-specific situation. We are also in the process of developing a model regulations for V2G, which I think one draft has already been circulated to the forum of regulators. Forum of regulators is going to that draft and trying to understand, okay, how to incorporate that and complement it for the better clarity and also addressing the state-specific conditions. So that process is going on, and I'm hopeful that soon enough we will have some kind of a regulatory framework which can be adopted by the states in the form of a model regulations. I was hoping that model regulations, I think, will bring out all the ambiguity which right now do exist in this particular new innovative technology, to actually understand what kind of a different roles, even being an aggregator or even being a distribution company, I need to play for promotion of such a new technology. And I think that regulations is going to serve the need of this particular sector. In addition to that, I think what is important from a regulatory perspective that whatever the technical standard required in order to interact or have this kind of a real-time interaction with the grid is also very key. And I'm sure the competent authority CA is already working on that and already come out with some certain provisions in this regard. So that is another kind of I would say a prerequisite for prerequisite framework, a policy and the regulatory framework which will push this new technology. But nonetheless, I think the kind of a pilot and the regulatory sandbox experiments done by the ISGF will certainly help the regulators to push it further and try to achieve it as early as possible rather than wait for a complete sector to respond. So I'm hoping and quite positive about this.
Thank you so much, Ravindraji, for your perspective, as well as for your support from CRC for giving us inputs towards the model regulation shared, as well as giving us an opportunity to present it to FOR. And I'm very, very happy to hear that the FOR is already working on dynamic pricing and also homogeneous and adaptable models, model regulation for the states. So thank you so much, and I'll come back to you, for more inputs. Let me now shift to the global perspective, and would like to bring in Professor Rodney from University of Delaware. Let's begin, from University of Delaware. He has been our mentor for planning and delivering the demonstration that we have had, and together with the experience that the University of Delaware has had in early successful demonstrations on V2G around the world, and they have also shown how electric vehicles can send power back way back starting from 2012, when we were only talking about electric bus vehicles or electric infrastructure first. So I'm very, very proud to that we have our partnership with the University of Delaware, and thank you so much, Dr. Rodney and University of Delaware for your support. So Dr. Rodney, would like to hear from you, based on your work you have done in Delaware and also your experience with this project in India. What are the important lessons that can be that are learned, and how you suggest we should begin our journey with V2G in India, keeping in mind that the first demonstration, how it took off, and what experiences you'd like to share from other demonstrations from different geographies you have worked in. Also, one question which has come in the audience, just quickly, if you can touch upon that, if there are any studies that have been conducted to check the harmonics effect on the grid when we are doing V2G. Over to you.
Yeah, Dr. Rodney starts. I would like to inform that Ghanshyam sir has joined the webinar.
Dr. Rodney, if we can just have Mr. Ghanshyamji deliver a special address before we continue with the panel, if that is okay. Can we invite Ghanshyamji on the...
Adina, I think continue. I just joined, so let me have the feel.
So you would like to hear first. Okay. All right. Thank you so much, sir, for joining us. And over to you, Dr. Rodney, for your inputs.
So one thing to the question you posed, electric vehicles that are bidirectional meet the same requirements as PV inverters. So here, as in India, since you guys have adopted IEEE 1547, those give the limits for harmonics and power quality. So vehicles meet those same requirements. We also have functions in the charging station, which provide grid protective functions. So the way to think of it is, if it's an AC charging station, the power simply flows through the charging station and the power conversion is on the vehicle. In that case, the charging station can function like a protective relay. It can, protect against bad quality power. And so those are the two ways it's addressed. We expect the vehicle to meet the requirements of IEEE 1547 to be interconnected. There's a handshake before discharging into the grid. And then additionally, if maybe something was done with the vehicle or it's been damaged in some way where it's no longer making good quality power, the charging station can disconnect it. In that way, it's actually a little bit better than PV because of this two-party relationship where the charging station may also have the trusted monitoring or metering or whatever is in there, and then the different vehicles come in and plug in. I think some of the lessons was your other question that we've learned from demonstration projects. Initially, not necessarily our projects, but many projects, they were afraid really to get the OEMs deeply involved with the process of making vehicle to grid work. So many of the early projects were DC based, and no one has really demonstrated economically the use case for DC V2G. Generally, DC is about charging vehicles quickly, moving them through. The whole point of V2G is to have as many cars plugged in sitting, right? So we need to connect them to the infrastructure where they park. not at filling stations, essentially. So what does that require? That requires that bidirectionality be built into the car. One of the things that has changed the perspective on that is many OEMs have bidirectionality built in. Vehicle to load has become a very popular feature. That's the beginning of bidirectionality. Vehicle to home is very similar to vehicle to grid. There's additional equipment and isolation devices, and I have to explain backup power to Europeans. We use it in America, use it in India, but I don't have to explain that to you guys. So the power of vehicles being used as backup power is very important. The cheapest way to buy batteries in the world is in a vehicle. So for a consumer to have a larger backup system at their house, certainly a vehicle could provide that. Customers pay for those functions. So Ford has rolled out their system of bidirectional. That one uses DC as kind of a quick to market kind of thing, but you're seeing many OEMs now adopting AC bidirectionality. The other point for this project, we used SAE J3068 style communications, and those allow for a seamless transition between the vehicle to grid modes and the vehicle to home modes. We weren't demonstrating backup power for this project because we were doing installations at commercial sites, but one of the key advantages of that system is you can switch between providing grid services to backup power in like a second with coordination with the isolation device in the house. We think that's a very key feature. As for the OEM integrations, I think the largest electric vehicle manufacturer in the world is BYD. They integrate their onboard charger and their vehicle to load functionality and the drive inverter into one box. That's the way forward for AC bidirectionality, because you're not looking at a significant incremental cost. It's very difficult to develop such a platform. It takes a lot of engineering, but the benefit is you get one box responsible for all the conversion between DC and AC, whether that's going off the vehicle or that's going into the motor. Although typical separate onboard charger systems with bidirectional functions can also be achieved, but using an integrated system gives higher power with decreased marginal costs. So I think those are the big key points we wanted to hit.
Thank you so much, Dr. Rodney, for covering all the different aspects around what we've been looking for in terms of creating an ecosystem to be able to scale up V2G in India. So thank you. And now I would like to, Sir Ghanshyamji, could we request you for your thing, or should we move on?
Yeah. But
Thank you so much, Ghanshyamji, for joining us. Sir is the chairperson from Central Electricity Authority, has been really supportive of all the new developments, new projects that we've been looking forward to bringing. And thank you for your support in the being our early movers and partner for V2G project also, sir. So over to you for your special address, and we look forward to your continued support in this.
Thank you, ISGF, for inviting me to be here. Incidentally, I wanted to be right from the beginning to learn what exactly is happening in this particular area. I just had a few glimpses in your earlier display at Delhi. Incidentally, I could not be there because of Honorable Minister, which was scheduled at the last moment. Anyway, but I see a vehicle to grid to be an emerging area, particularly for the Indian conditions. And Abhishek being there, I think the DISCOMs are more in need of such alternatives, wherein their reliability gets shifted to the consumer themselves. So, I mean, slowly and slowly, the area where we are moving to, and particularly with more of uh, rooftop solar coming in and people becoming decentralized or DERs being promoted. So people now is towards more and more EV penetrations. And once we have these EV penetrations right now, even though it is at around 7 to 8% in India, but slowly and slowly the pace at which it is moving further, I see a good amount. And mostly what happens in similar to the Western world, in India also people are now going to have multiple vehicles in their own house, and most of them are idling. So there is going to be a good opportunity for such idling vehicles to support the grid, provided there is a good mechanism of compensating these people in such time frames. The mechanism will have to be developed. There has to be a good SOP type of things, or maybe the DISCOMs can come out with innovative commercial mechanisms and ease of getting them on board, so that these people get encouraged to be there. I know it is going to be a very, very difficult, and many a times it may not work as well, because you never know at what time you are going to use your own vehicle. And that totally depends on the urgency and the need of our. But still, even of taking a factor of safety, even if 50% of such vehicles are able to contribute to this, I think is going to be a good numbers. Or maybe initially we can take even a lesser number of, say, 10% or 15%, which I think is going to be a good thing. So I see it as an emerging support, because going I see is there's going to be a huge demand in terms of the storage, particularly, and evening hours. And if that is going to come, alone grid element may not serve the entire purpose. And if the DERs along with the storage or such mechanisms, particularly vehicle to grid also, of course there will be some more challenges, technicalities. Standardization will have to be done. The manner in which they are going to support to the grid, the technical parameters, these standards, all those things needs to be followed. Next is the safety margins, safety factors also needs to be taken care. So all these things are definitely there. But besides that, what is probably going to be more and more important is the mechanism of engaging such people and taking it on board to the distribution utilities. So the concept which I always keep on telling now is the generators, which used to be a conventional large generators, is now going to be a smaller ones, and right at the place where you really need it. And the only thing is we need to facilitate such kind of a mechanism to get to. Good to hear from you all people, and I hope Reena will share with me what all happened in my absence, so that at least I get updated. Thank you so much.
Thank you so much, Ghanshyamji, and definitely we will put together all the notes of the webinar and share with you along with the presentation which Anand just made. And I'm very happy to share there are 204 participants who have joined us and are currently with us, and very, very actively participating in the chat, in posting very good questions. And I'm very happy that some of the panelists are also responding parallelly. So thank you once again, sir, for
Thank
your
you, sir. Thank you very much.
words, and you perfectly have set the tone for today's discussion, for moving the direction which is needed to unlock the full potential of V2G, and importance of different parameters required to scale it up. So thank you, and we will be back with you for more guidance. So with that, let me bring our utility leaders who have put in a lot of effort in making this possible on ground. utilities like BRPL, they have been they've had the first-hand experience with the Delhi V2G pilot and offering critical insights into the operational realities of the project. And I would like to bring in Mr. Abhishek Ranjan, CEO of BRPL. Ms. Ranjan, BRPL, and you played a key role in testing of how V2G can work in the real world urban distribution networks in India. And so from BRPL's involvement in the Delhi project, what do you think, how feasible is V2G from a utilities commercial and operational perspective? Would like your inputs to that. Over to you, and warm welcome, Mr. Ranjan.
Thank you, Reena, and thank you, ISGF, for this warm welcome and the opportunity to participate in today's interaction. In fact, this V2G may be a very new concept here today, may not be appreciated as a very significant part of our network planning, but I see a very important constituent. Today I was discussing the CAPEX plan for the next 5 years, and I see the wired CAPEX to be moving down slowly downwards, while these non-wired, like flexible assets, including V2G, such assets should go up. The cost, the investment in these should go up. Overall cost burden on the consumer should be coming down. Now, the beauty in expanding these, especially the V2G as one of the important flexible asset, is it can be time controlled. And unlike, say, for example, cooling load, which is required when it is required when the temperatures are very high. But the vehicle to grid or the vehicular EV load can be programmed and can be planned that way, unlike a cooling load deferral or something. So that is a good part where the conversion and the likedness by the consumer, we believe, is going to be very high. In fact, we did a survey also that was in 2020. And there also the customers expressed the similar kind of views. Of course, 5 years have gone by, maybe something else is going to come by. Now, your question, how do you commercially expand this? Okay, so as was also talked about by Professor, that such individual feeder level, for example, when you talk about a two-wheeler, three-wheeler or a four-wheeler, that is the battery size up to maybe 60 kilowatt hour, 70 kilowatt hour. I'm talking about cars, for example. The individual level, the contribution might be very, very low. But when we try to commercialize it in a place like, for example, there is a mass parking lot like International Airport, or maybe you have metro stations where dedicated floors are there and they together get aggregated and then, in unison they provide. Just like similarly like battery swapping stations where maybe we have seen battery swappers where auto rickshaw battery storages. Those units may be in multiples of say 10, 20, they are together and then they deliver in a composite fashion to the grid. That also we did some time back. So, so these places will be very important. The second important place is the e-buses, V2G from electric buses charging station. Their battery size is also very, very high. So there they can be deployed in a very distributed way. So the good part is we can plan them. These are battery on wheels, which can be deployed at a place where the congestion, local congestion is there to relieve it. And this may also play a very important role in formulation of LMPs. So location marginal pricing, if at all it comes in India, as and when later point in time. But yes, today very two strong use cases are, one is the CAPEX deferral of the grid or reliability enhancement, that is one, which has to be location based and time based. And second is of course the energy arbitrage benefit, where the grid or the utility pays for this at a rate lower than otherwise it would have to pay for a costly power resources to be capitalized. So it can be another way also, if it is firm, can be a part of our RA plan as well. So it can be expanded, yes. Only some regulatory nudges or some support would be required, but definitely I don't see much hurdle over there. In case we are able to bring the value on the table even today, given the exchange rates or maybe SRMC, it can be, fruitful. Reena, over to you.
Thank you so much, Mr. Ranjan, for very, very insightful pointers you have given on V2G usage and the requirement for scaling it up. Actually, looking at it as capex deferral mechanism and using it for energy arbitrage benefits that the utility is looking at. And as an aggregator model, definitely, I think that's an excellent suggestion that this will, bring a huge relief, load relief, unlike, the cooling load and can be planned better at the time of peak. So thank you so much for those key points and very valuable inputs. I'll come back to you for more if time permits. And so let me now bring in experience from Kerala before we go back to our utilities in Delhi. I would like to invite Mr. Narendranath Villery from Enert, Kerala. And Kerala has brings its own unique energy profile, and Enert's role in the pilot has added important regional diversity to the conversation that we were looking for. The state's focus on clean energy and decentralized systems makes it an important testing ground for the emerging technology like V2G. And would like to take your perspective, Mr. Villery, on what have been the key learnings from Enert's involvement in this V2G pilot, and how do you see this scaling up in Kerala or similar states?
Thank you. So as such, we had this plan. My ex-boss, so he always used to tell, we have this problem of availability of land in Kerala. So instead of mass storage, we should be focusing on storage by masses. So that is where we were. It's not just the government, including the regulatory commission also. So was pushing hard for something on the storage. So that is where. So even the draft regulations of KSCRC also mentions about this V2G and how to operationalize this V2G. So in that context, so actually we collaborated with you, and so we got the vehicle. So when we were trying to get the connectivity and all, so it was really a very fresh experience, a new experience for the Chief Electrical Inspectorate. So then the regulator, so there were teams from all these offices coming, visiting, and so to understand, because they have brought in the for the battery, they have brought in the regulation, the guidelines by the Chief Electrical Inspectorate, but seeing it and actually experiencing it was the major thing. So then they went back to their board, and then they have made the modifications what will be required in the battery storage and all. And so that way it was an eye opener for everybody, including for the DISCOM, on how it has to take up. In fact, the regulator always from the past 5-6 months they were telling, so if people invest on battery, so then we'll be ready to approve the difference or the rate at which the KSEB is purchasing at night rate. So we are ready to approve. So that is a very positive intent. And Kerala, as you know, after maybe Delhi, so we are the second fastest in the EV segment. And as such, if there is some technology that is eco-friendly, Kerala will be the first state to adopt it. Even if you see PM Suryagar also, we are when compared to Gujarat and Maharashtra, I think after UP, I think we are the 4th best performing state in PM Suryagar, almost 1.5 lakh installations till date. So that way there is huge adaptability. So in fact, after the inauguration here, so I was surprised to see a bus full of students coming to see this from the engineering college here. So that itself shows that people are well aware and they wanted to embrace this and take it forward. So that way, means the state has the intent. So that is why we insisted on this technology pilot to happen. So then the regulator is clear. So the DISCOM is eagerly waiting when will the mass storage come in, because so their storage plans are next 12 to 18 months down the line. So that way it is all ready for Kerala to adopt this technology. We have already discussed on a roadmap on what are the short-term, medium-term, and long-term, how to scale this technology. And my current boss is also interested in taking it to the next level, not just stopping at the pilot level. So hopefully we'll be working with you closely for the next few months to take this to the next level.
Thank you so much, Mr. Ellery, for your support, and of course, not to miss out all the support that Jyotilalji has offered to ISGF, particularly for this program. And I know he always talks about this as instead of mass storage, storage by the mass, very rightly put together. And I'm very happy. We are very happy to see that Kerala has already had the guidelines around V2G in place in the current draft that they have put together, and all the uptake that you see for EVs going forward. Kerala could be leading in V2G demonstration, and V2G actually becoming a reality. So thank you so much, and we'll be very happy to work with you closely on making that happen. So with that, I would like to invite Mr. H.C. Sharma, TPDDL from TPDDL. TPDDL has been a pioneer in smart grid infrastructure and very crucial for integrating V2G into existing systems. And their experience in automation, demand response, ER integration places them at forefront of grid modernization, in India. And Mr. Sharma, what do you see as the main infrastructure and integration challenge for implementing V2G at scale? We've heard from the policy perspective, but and from Abhishek ji as the requirement perspective, and over to you to get some insights on infrastructure and integration challenges that you see as for scaling up V2G implementation.
Thank you, Rina. First of all, I would like to actually bring out the potential. I was seeing the numbers. So seeing the numbers, say right now we are having around 3 lakhs vehicle in Delhi. I would take a small example of Delhi only. Am I audible? Otherwise, there is no issue?
Yes, we can hear you very well.
Yeah. So what happens is that, say, suppose we talk of 2030, so we expect around 2 million vehicles, and 2 million vehicles with the meager 40 kilowatt hour battery in it. That makes a huge energy storage. So around 80 MU energy is stored in these vehicles. And right now, just to give in data, the daily consumption is toggling between even in the summer between 100 to 150. So such a huge battery system which is available, which can supply Delhi for half a day or more. Now we have to see, of course, there would be like some of the vehicles would be running, some of may not be connected. So all those corrections would happen. But we can think of what is the potential we have. Now the challenge is that how we bring out this particular energy, to DISCOM level and finally to the customer level. There may be certain challenges, and how it can be used for a DISCOM, it can be used for peak saving also. That is the first thing, probably because this is around 10% peak. If we save only 10 occasions, we would be almost 10 to 15 occasions, we would be using the energy storage. So that is not a huge number of cycles which we will be using, but that can make a great impact that peak would be saved off by 10%. Even from Delhi perspective, we are not able to totally island Delhi from the entire Delhi supplying energy from internal sources if something happens to grid. So probably with the battery and its uses coming into the real use, probably islanding would be possible for Delhi. And of course, the grid stability is another part. There would be different facilitators, and of course, there would be infrastructure and challenges which are there, which you, Reena has asked about that. So this ground making was necessary because what is the potential we have and how it can be utilized. For infrastructure part of it, of course, DISCOM side, it is being planned each and every year, the requirement of the infrastructure. Of course, based on the forecasting of the numbers and how actually number goes in future, there may be some tweaking in the infrastructure. But how we can take this energy to the real customer, how we can utilize, there would be challenges in terms of regulatory, first of all. So of course, the discussion has already happened on the regulatory part of it. Another maybe from manufacturing point of view also. See, all the manufacturers of the car has to come on the same platform. Otherwise, like we are on a very initial stage right now. We have to integrate the manufacturers, DISCOMs, and like starting from the regulators in car manufacturing area, also in the electricity distribution also, and all the regulators have to come at one platform and then see that how energy flow is smoothly happens from car to the grid and grid to car. So V2G happens on both the sides. So all the regulators have to think about it. Right now, the cars are coming, they are not capable of. Of course, they have a potential, but we cannot utilize. So this is one which is in a way is a challenge to bring out so many stakeholders at A, but it is possible. It is not like that. This is not possible. Then we have to develop, of course, the platform and all for all this to happen, so that smooth flow happens. So I'm sure about it. People are on the job, and this is not a very big issue. This can happen. Third is like standardization of the charger communication system. Of course, the regulators, if all the regulators come, then definitely that has to be made happen. Otherwise, there would be like somebody is going in north, somebody is going into south. So that type of thing would remain. And for arbitrage point of view, still I have a question for Dr. Ronnie, that how it will affect the life of the battery is still not very clear, at least to me. If we every day we have one cycle of charge and recharge with the batteries of the car, how finally it will affect the life. Of course, I feel that this is going to affect, but how we can minimize the effect, that is again a challenge, and that need to be addressed to give assurance to the car owner that you are not going to lose in a big way by giving the consent to use as a storage system. So I think these are the few things. Of course, detail, if we start working on each area, many details are there, many things would come. But these are things right now in my mind which are coming, that we need to work on all these areas to make it happen. And second is like, I was just going through that this is not only like taking back energy from the car. See, it can be used when grid is like oversupplied. We can use and we can charge them also. So it's a both way, like flow of energy both ways. So we can make the grid more stable also. Huge potential, excellent opportunity. How we utilize it, that is our capability. Thank you very much.
Thank you so much, Mr. Sharma, for highlighting those on-ground technical considerations that are required, need for standardization, and of course, load balancing strategies, with the V2G becoming a reality as we scale up with that. So, and your question on arbitrage, I think, Dr. Rodney, I'm going to come back to you. Let me. We have three more speakers, panelists before I come back to you. So please stay with us. I would like to now invite Brajesh ji from BYPL. Over to you, Brajesh ji. Would like to hear from you. How do you see DISCOMs preparing both operationally and strategically for a future where EVs can act as mobile batteries. I know some perspective has been shared, but would like to take your perspective on this point, from CEO from BYPL. Over to you.
First of all, thank you, Reena, for giving the opportunity. And also thanks to ISGF for doing this pilot with BSES along with Tata in Delhi. So what I would like to say is that EV as mobile batteries definitely can support the grid and help utility in managing demand at critical events. As Abhishek has said, Delhi is having the most number of EV buses, like around 2,500 EV buses, which can support the grid to the tune of around 20 megawatt at present. But going forward by 2030, they will be having around 10,000 EV buses. So it will go up to 100 megawatt also. So this is how it will help us in because Delhi has two peaks. One is in the afternoon when the lunchtime is there, and one is in the night when the buses goes to the depot. So this can definitely help the distribution companies in managing their peaks. As DISCOM is concerned, DISCOM may have to invest a lot in grid modernization to make bidirectional energy flow from manageable, and for preparing itself will have to invest in grid infrastructure, including IoT-enabled substations, bidirectional meters and all. So this is what DISCOM has to do for getting this EV to V2G technology implemented in the system. Thirdly, what I would like to say, DISCOM should also pilot the aggregator model to pool distributed EV batteries for grid service at the time of peak. And one pilot which we are already doing with the ISGF, this will give us a numbers that how we can utilize this V2G to support our grid. Thirdly, DISCOM and regulators also needs to sit together for tariff innovation and introduce customer incentive, designing V2G specific time TOD tariff, and also reward the EV consumers, EV owners for discharging during the peak hours. This is what is required. The most important part is we should also consider the cyber security so that the V2G communication protocol does not impact our grid system and our SCADA system. So this is also be taken care of. To enable and coordinate grid support, government and other agencies need to bring the bulk EV operators on a common platform for easy interaction with the DISCOM system. The EV operators have their own systems which don't interact with each other, so the government and the DISCOMs have to come forward for getting this aggregated for the demand flexibility support. Thank you.
Thank you, Brajesh. Very, very good points highlighted around the requirement of regulation, deferral of capex with V2G, and other aspects around like the inputs from the pilots to be taken up and aggregated before planning for the next pilots and scaling up projects. So with that, let me now bring in the perspective of EV manufacturer, as we've all been waiting to hear from vehicle side technology, which is at cornerstone of V2G, and Tata Motors involvement has given us a lot of insight around the possibility of making this happening. Now we would like to hear more from the product readiness landscape going forward for scaling up. Tata Motors is one of the few OEMs in India actively exploring bi-directional. We understand there are already bi-directional module available in the latest models that Tata Motor has been working on. Mr. Omkar, from Tata Motors standpoint, how feasible is the integration of onboard bidirectional charging into EV models, and are we close to commercial deployment currently? What is the landscape we are looking at? Over to you.
you, Renan. And now I must thank ISGF for giving us this opportunity to participate in this pilot while you retrofitted our cars. But why we wanted to actively participate in this as an OEM is to get a perspective of how this will shape up. Because as you all know that we have the largest number of EV cars in India, and we as Tata Group, not just Tata Motors, are committed to make electrification a reality in India. And one of the major aspects of that is how do we make electrification sustainable. And V2G is obviously one of the major aspects to make it sustainable. And to make that, I think from a technology perspective, if you have seen the cars now, they can, they have become gadgets. You can make anything and everything possible in cars. But the real question that we keep asking ourselves from a EV manufacturer perspective, that will the consumer pay for it? And for any feature, for example, you see so many features like ADAS, and other, many advanced features. If the consumers are ready to pay for it, we as EV OEMs would be very happy to give those features. And whatever technological advancements have to be made to make that happen, we will make it. So the real question that we want to ask, and obviously we will get to know through this pilot and obviously through the larger cohort that is here, is what is in it for the consumer? If the consumer gets benefit, and as many of the esteemed panelists said that there has to be a regulation around differential tariff, time of the tariff, etc. If the consumer sees benefit in it and is ready to pay for this technology, I think everything else will fall in place. We have to make that thing happen. If the consumer demands, everything, we will put the technology in the DISCOMs can enable the technology from the grid side, because then there is a pull in the market. You don't have to push anything. So that's one aspect. From a readiness perspective, I think as Rodney also put it in the chat, most of our cars, including Nexon, the latest Harrier.EV, all of these cars, and also Curve.EV, these three of our flagship products already have a bidirectional charger in the car. So we call it V2L capability, vehicle to load capability. So the charger, the same charger that takes the grid power and converts it into DC to charge the battery, has a bidirectional capability. So it can also take the battery DC power and convert into AC power. The question that we are asking ourselves, that how do we make it synchronized with the grid? While this AC power is being developed by the car or generated by the car, how do we ensure that it is in sync with the grid? And what are the standards that need to be followed to ensure that the development is standardized across the cars or across the makers? So capability is there, and if we can get the right standards in, and all our DISCOM colleagues can help us in that. If there are standards which we have to comply, and ARA and other agencies are also made aware about it, because this we witnessed 4 years back or 5 years back when we started electrification journey in India, when charging standards were being developed. So while V2G is what we are talking now, G2V, the opposite side, grid to vehicle charging, is something that was standardized 5 years back. We had a set norms that everybody has to follow this. We followed that, and now you can see a lot of standardization across, at least in four-wheeler domain, I can say. That CCS2 is a standard. Everybody follows the same voltage levels. Everybody follows the same area standards. So if that can be provided to us, and there is a consumer pull, I think this is matter of time. It can be made easily available. Another very interesting use case that we are seeing is vehicle to grid is obviously when we supply to grid and in high peak conditions, etc., it can help. But one more big use case that we are seeing is during the power outages. Can the vehicles serve as a battery backup for the houses? Still in many parts of the country there are intermittent power outages. If the vehicle can also seamlessly serve as a inverter per se, home inverter per se, I think that will be a huge game changer for Indian industry as a whole. And if there are any technological or regulatory perspectives on that, we would to take that forward as well. So we call it V2H. So V2H will be a stepping stone for us to go to V2G. Yeah. So back to you, Rina.
Thank you so much, Omkarji, for touching upon all those perspectives around readiness, not only readiness of the technology, but consumer readiness is also key in increasing the demand. And I'm very happy to hear that you already have V2L, V2H variants, which is going to play a key role for supporting in power outages and providing load battery backup support for areas which do not have power. But just very briefly, coming back to you on the question around battery, we have had, while in FOR also we had the question around impact on the battery with this, and now you already have these variants which are bi-directional. Do you have any data which says the impact on the battery for this kind of a reverse flow?
Yeah, there have been a lot of.
Okay, sorry.
Oh, sorry, I thought that was.
Go on, Rodney.
Well, yeah, I was going to say there have been a lot of really good studies, and it would be hard to just answer that question because it depends on what you're doing with the battery. I would search those studies and pull them up, but I think the main thing you will find is that the effect is pretty minimal when it compares to calendar aging and driving, which is the most aggressive thing you do with the vehicle, hundreds of kilowatts stopping, going. And some of the studies have shown that simply combining V2G with smart charging, meaning SOC management, can offset it. So batteries don't like being really empty or really full, lithium-ion batteries. So if you can manage that SOC, and obviously the worst case scenario would just be energy arbitrage, right? Moving tons of kilowatt hours through the battery, but that also pays the least amount of money. So that would be part of the decision for the battery wear.
Mm-hmm.
But yeah, this has been studied pretty well, and it all depends on the service. And someone said, well, where do aggregators or other kinds of people come in? Well, somebody needs to figure out, does it make sense to use this vehicle for storage for this purpose? Right? It's an economic kind of study, and that's kind of how you make that decision to do that. And overall, the effect, depending on the use case, is pretty low. You're talking about over, for some V2G use cases over the lifetime of the vehicle, a few percent total difference. Like, a few percentage. But again, depends on the use case. If you're using the vehicle for backup power, also, that's got to be factored in, but that has value to the customer specifically also.
Thank you, Dr. Rodney. And Omkarji, would you like to add something to what Dr. Rodney has shared?
Yeah, so same perspective, right? It is as good as battery usage. So it depends on application, if it is a peak shaving application or if you're actively supplying power to grid for longer durations. But think of it in a very different perspective that let's say as manufacturers we offer warranty for X number of kilometers, and X number of Y number of years, and so this is as good as consuming your kilometers, because you're essentially consuming the battery cycles. So as long as there is commercial sense for the customer, I don't think the customer would mind spending few kilometers on this, because as Rodney rightly mentioned, if it is just peak shaving or some minimal grid supply applications, then you're not going to consume significant number of cycles in this, because if the cycles are minimal and consumers get benefit, I think consumers will be very happy to give it to grid. So it all depends on how do we make it happen.
Great. Thank you. I think that's quite reassuring to hear because there were a lot of queries around impact on the battery from our regulators as well as a lot of other stakeholders we've been interacting with. So let me move to our last panelist for his inputs before we go around for a quick closing remarks for all. Let me have Mr. Balaji Raparthi from Shakti Sustainable Energy Foundation. So Balaji, from perspective of foundations and think tanks, what do you think is since they play a key role in shaping a lot of policy frameworks and bridging the implementation gaps, and you also bring in a lot of different stakeholders together to advocate on enabling new technologies and policies. So what role do you see, philanthropic organizations or research organizations playing in advancing V2G adoption across India? Over to you.
Yeah, thank you, Reenaji. Hope I am audible.
Yes, you
So
are
first of
audible.
all, I would like to congratulate ISGF for this first of its kind demonstration that we have done in 2 states, and I'm actually personally we are very happy to be part of this demonstration as knowledge partners. And yes, coming on to the part of role of philanthropies and think tanks in bringing in this into the full scale implementation. So as Reggie sir has already mentioned, so be it be any technology, be it be smart metering, rooftop technology, or be it a demand response. So any technology when it comes, so it needs to go through a process before going into the full scale implementation. So as philanthropies together with think tanks, we should play a role of system change enabler, because it is a new technology. People are not aware of it. They don't know about the technical feasibility and financial feasibility. So they want to understand all these aspects. In a process, first we need to understand the literature review where, we need to understand, is it established in the overseas or internationally? Is the technology is feasible? Or is it financially also feasible? So we need to do some pilot projects post literature review. And then once we do that pilot projects, so based on pilot projects, we need to come up with 2 things. One is that reports which talks about, yes, it is financially feasible as well as technically also feasible. And also, do we have that technology in India or nearby at cost effective manner? Because one thing that we have done in this project is, of course, we got the support from University of Delaware. But do we have that capacity in India, or can we develop that capacity in India? So that is one of the aspects that we need to focus on. And then afterwards, we need to develop a regulatory sandbox, as our honorable panelist from CRC also has mentioned. So once we do with the pilot, for suppose our project, we have done the international case studies. Yes, V2G is possible. We have taken support from University of Delaware, and this has been in the pilot projects across the world. Netherlands has done it in one of its stadium through Nissan Leaf vehicles, and also with solar rooftop and with BESS as a backup option. And UK is doing so many pilot projects, and US, as Reggie sir has mentioned, US is doing school bus related aspect, and China is doing 30+ pilots as a national pilot scheme of V2G. And Europe is very much in advance, and especially France, if we see, they have come up with integrated energy contracts, energy market contracts for V2G. So these kind of various initiatives or instruments are in place. But what we need to see is, of course, we have done the pilot project. We have showcased that technically it is feasible, be it be retrofitted or be it be new, because new vehicles also there are various models. We have Nissan Leaf, we have Ford F50, F150, and BMW iX is there, Renault models are there, even Hyundai models are there. Of course, may not be in India, but they are already there in US, Europe, Australia. So these models are there. It is just the time that it has to come to India. But if that technology we have established in India through our pilot, but the next step is what needs to be done is on live demonstration. So we need to do a controlled environment demonstration and on grid demonstration. That is one aspect that we need to see. And then we need to come up with an regulatory toolkit. So what kind of policies should be in place? What kind of regulations should be in place, considering the cost economics? Like we need to include or enable this bidirectional flow of the power from vehicle to grid through our Electricity Act or policies, rules, and everything should be in place from the findings of our pilot. And then based on that, we also need to look at the financing side. So is it financially viable? If not, then how can we de-risk it? So that can, it is the place where the philanthropies can also play a role, the de-risking of a particular innovative technology. And also some schemes, like we came up with smart metering scheme. So we come up with RDSS scheme and RAPDRP, UDEL, and under various schemes, we have supported these particular technologies. So likewise, we need to work towards bringing in such schemes so that it would be feasible for DISCOMs also to introduce such schemes, because it is new kind of technology. And then of course the tariff. So what is, we have the charging related tariff, but we don't have discharge related tariff. So what should be the discharging tariff? And what should be the differential tariff? Like during the peak time, what should be the tariff, so that consumers will willingly and voluntarily come and give the power to the grid, and that should be economically viable, and then it should be actually encouraging to them, so that they would voluntarily participate in it. And another one is the license to the aggregators. Is there a possibility that charging point operators can aggregate the vehicles and give that? And is there a battery swapping option can be explored, where swapping batteries can be utilized during the peak time as an alternative value addition? So these aspects to be covered. Once if policy regulations and the guidelines are in place, then we can move forward towards the notification of regulations by consulting with various stakeholders. Then the capacity building aspect will come, then finally implementation. But when we go to implementation, we need to see, so for suppose electric vehicles are there. So the technology is already established and it's there from more than a decade. And in the US, it's been like more than 25 years. But the thing is like, the new technologies comes, so how can we accelerate the deployment of a particular technology? That should also be taken care of. So together, philanthropy and think tanks should work towards these aspects as a system change enablers. We have to give a toolkit of regulations. So these are the regulations that should be in place before implementing this kind of technology in the grid. And also we need to give value addition. Why consumers should participate in it? So they should get some value addition out of these kind of initiatives. And of course, as other speakers has already clearly mentioned, that of course it helps as decentralized storage and demand side of power supply. And of course, it can help lightening the homes, especially in the long power cut areas like villages and rural areas. So it is a game-changing technology. We need to take it forward. And of course, philanthropies and think tanks has a great role to play in taking it further, because now it is at the pilot stage, technical feasibility stage. We need to take it forward by creating the value, creating the live pilots across the nation. Now we have done only in 2 states, but we need to take it forward by demonstrating it in many states on live grid. So that is what I would like to add.
Thank you so much, Bali. Very, very good points you have brought in to have the right, regulatory landscape. We need, toolkit and have economically viable tariffs for increasing participation. So we need a lot of support from our state regulators for that. And of course, post demonstration, we have to work very, very hard towards building the capacity for scaling up in India. So I think that is a very valid point. And also looking at different models to scale up, talking about license to aggregators or education of consumers to be able to contribute to this and have the demand creation done. So thank you. This completes the whole picture with the system level perspective. Thank you so much, Balaji. And I think we're running very, very late with time. I don't know if we have time for one lightning round with our panelists for in one sentence or two. What would your input be for being the key or critical enabler that can help accelerate India's V2G transition over the next few years? So if Regis permits, I can just go around and in one line would like to take
Please,
inputs from our panelists. So
please.
let me start with Ravendraji. Very briefly, one line. What would be your input?
Difficult to explain in one line, but I think based on the discussion and the brainstorming we have, I think an appropriate incentive and the commercial signals with a of course complementary regulatory framework would make it possible, certainly. Yeah.
Thank you, Ravinji. And Abhishek ji, would you like to give your perspective or input for this question?
Yeah, sorry, Reena, can you repeat the question for me?
Yeah, just in one sentence, what do you think is one of the critical enabler for accelerating V2G transition in India in the coming years?
Regulatory recognition is the key thing. So just like the BESS got a regulatory recognition, and also the definition was very much clarified by Ministry of Power, Government of India. Similar thing has to be enabled, and then rest follows.
Thank you so much, Abhishek ji. Narendra ji, would you like to give your inputs before we close?
The OEM's assurance and the scaling up these pilots so that it is available. So only these things can proliferate it. Then regulator will fall in line. If people are demanding, regulator should be falling in line.
Thank you, Narendra ji. And Brajesh ji, what is your one point on the critical enabler?
It's already been repeated by many panelists. The main thing is that comprehensive national regulatory framework is required, and some incentive to the participating owners of the EV should be there in that regulatory framework, along with if time of use tariff can be introduced by the regulator.
Great, thank you. And over to you, Mr. S.C. Sharma.
Yeah. Actually, regulatory, of course, is the key enabler. Apart from regulatory part of it, like this is technically we are on pilot stage, and this has to be seen for some more time so that we take it further. So technically, also we have to work out a system which is like a robust system which can be implemented.
Thank you, Mr. Sharma. And Dr. Rodney, what is your suggestion for India's uptake for V2G?
Yeah, the two key things are that you don't consider systems, don't do systems that are very expensive as your to sort of pave the way, because it sets the precedent that, oh, this is very expensive. All right, we mentioned there's been a lot of mistakes on using DC fast chargers as V2G stations, and so that's a bad path. We've talked about the other path of building off of the vehicle to load, the H to G. And the technology is not really the problem. The understanding of the technology in any particular area is the key. And it's mostly techno-regulatory is the problem, not actually technology. It's where those two things meet, because as you've said, we've been doing V2G for almost 20 years. We have some vehicles that have almost been operating that long. So the technology can be had. It's about creating, the availability and the ease of interconnect.
Thank you, Dr. Rodney. Very good points there. Over to you, Omkarji, for your inputs.
If I were just to build on what Rodney said, it's commercial, techno, and regulatory, all three aspects. Obviously, the consumer should say sense. The technology, while we will develop technology jointly with everybody, but it has to be robust. It has to be as simple as plugging in your car, setting some parameters, and it works. Because if that doesn't happen, consumers will never adopt it. And third is regulatory, obviously. When regulation accepts this, this will just fly.
Thank you, Omkarji. And lastly, would like to come to Balaji. What are your inputs?
I think like everybody has covered it, but of course, apart from conducive policy environment and regulatory environment, and we should also have indigenous technology and capacity building to be in place along with these things. So parallelly, if both can happen, so you can see the success. Okay.
Thank you so much to everyone for your inputs. Our panelists have given very, very valuable points for today's discussion. And this webinar is not just going to end, but I think with this webinar, we have started a national dialogue on how we would like to move forward, what are the things to be taken care of to scale up V2G, and how, and I think there's no reason now with this demonstration to not understand the importance of vehicle to grid, and the technology is definitely a key enabler in going forward in supporting many areas, the utility and bringing the flexibility. So with those words, a big thank you to all the panelists, and I hand over the stage to Mr. Reggie Pillai for thanking our panelists and closing his closing remarks. Over to you, sir.
Thank you very much. We had a wonderful session, and thanks to all the speakers, panelists for their valuable input. And we had more than 200 participants for most part of the webinar. And even now we have more than 100 people connected. We are more than 30 minutes we have spent extra than originally scheduled. It only indicates that this is an idea whose time has come, and as many of you who understand the Indian power system know, these days, even in the summer afternoon, we have surplus power on the grid. High solar generation hours, there is surplus power on the grid. This can come at 1 rupee, 2 rupee, or less than 2 rupee per kilowatt hour. It's available, which can be charged in the EVs which are parked in your offices and homes. And evening peak hour, you can discharge it at 2x or 3x, whatever the regulator will approve it. And this is going to be the, as Mrs. Sharma had told, it's going to be the largest distributed storage capacity which we can build in no time. It can happen once the commercially available vehicles and chargers are available. I'm sure if Tata Motors launch a V2G variant of Tata Nexon, along with that, they will be giving a 10 kilowatt, 5 kilowatt, some appropriate charger along with that, like a AC charger is given with vehicles today. So you can install it in your houses. You can participate in the V2G program. Either the aggregators will come and do that, or utilities can directly manage it through DISCOMs when they have it. So a signal can be given when to charge, when to discharge. And what we are trying to do is to develop some mobile apps here, which even drivers can use it. The platforms available overseas are all are for educated people. Vehicle owners are participating in V2G, but in our case, most of the vehicles are driven by semi-literate drivers, so they should be able to do it on their mobile phone in vernacular language, when to charge, when to discharge. In the pilot project which we have done, I need an engineer with a laptop to charge and discharge. If we have to do it other than the scheduled time, we have scheduled some timing or on the fleet box of Nuvve. We automated some time. Other than that, if we have to do something, then we need a laptop and all that. So this will need to evolve. It will evolve, and we are sure with the support of regulators, with the support of OEMs and utilities, we hope before end of this decade there will be millions of V2G capable vehicles supporting the grid. And this is also very, very important, as I mentioned, because of the rooftops, which is scaling up everywhere, mushrooming on every building. Rooftop solar is coming. So to manage that, we need distributed storage, which will be the EV, and which will be a win-win solution for everybody. And thank you once again to everybody. And as most of the questions which were there were very valid technical questions also. Me and Rodney tried to answer most of the questions in the chat box, and all this will be available along with the video recordings to all the registered participants within 2 days. Thank you very much, and good evening, good day.